Welcome back to a video series in week 7. And the problem we are going to do now is rather complex, but not as complex as the problem that we will look at pretty soon. And in the series of videos before this one, I have presented you the 3 different kinds of concentration units. One of them was molarity, the other one was molality, and 2 subdivisions that are volume percent and mass percent. Okay. In this particular problem, we are going to combine 2 out of those 3 concentration terms and solve a problem. Okay, so as always with any questions, first figure out what does the question want you to do and what is the information that's given. In this particular question, the question asks you to figure out molarity. It didn't tell you that you're given molality, but the term here has got the lowercase m, which indicates you're given molality. Okay, it didn't come out explicitly and say you're given molality, but it's given the information with the unit. So it's a unit that's very, very, very important. And the question also has provided you with the density. Now, for this problem or any other problem in the remainder of the course, density refers to density of the solution, okay? It's important that you make that distinction between solution, solute, and solvent. If not, you're going to have a lot of problem at your ends. All right, so density of solution. Okay, now why is that important? Because let's come back and write something here to tie back what we just mentioned about density. Molarity, the textbook definition is moles of solute, okay, over a liter of solution. Okay, now it is equally important that you also remember the units. And it's not a big surprise because we have written the definition. The unit is just a simpler version of the definition itself. And this is the units for molarity and is also referred by uppercase M. Right? While it's important that you remember M, it's also equally important you remember the actual unit for molarity, because this is what will help you in solving problems. Now let's get the definition of the second term that's in here. It's molality. Okay, and that is also moles of solute over a kilogram of solvent. Okay, again, the unit for that is moles over kilogram or m. Okay, now the bottom line of this problem is, if you notice these 2 units within the black and the pink circles, the numerator is exactly the same, which means we don't need to even solve that part. It's only converting the kilogram of the solvent to a liter of the solution is going to be the only focus of this remainder of the problem. All right, now let's go get another color. Okay, so what does this mean? Well, the molality of our solution is 21.4 molar, right? That literally translates as 21.4 moles over a kilogram of solvent. That's what it literally translates as, right? So we already know the numerator in our final answer. We just have to figure this out, then we can put them together and we're done with the problem, right? So this is already done. Now let's go break down something else. Okay, we already know the density. So if we can find the mass of the solution, why do I need mass of solution? Well, if you think about it, density is given in grams per milliliter, right? We want liter. So that means somehow we got to get rid of the gram and the density. So we will have milliliters, which we can then convert it to liters to get it in here, right? So if and what do we need to find is not mass of solute or solvent. We need to find the mass of the solution, which is nothing but mass of solvent plus mass of solute. Well, again, the problem is complex, but it's got a lot of information hidden that as we dig deep, we're discovering them, right? Well, we know this is a kilogram of solvent. So the mass of solvent is already known, and I'm just doing the conversion in my mind and writing it, okay? So we already know this information. It's 1,000 grams. 1 kilogram is 1,000 grams. So if we can find the mass of solute, then we know the mass of the solution. Well, I have an answer for that as well. So let's go get our blue and work this out. Okay, we do know the mass of the solute, right? So if you can go from grams to moles using molar mass, right? To go from grams to moles, you need to use molar mass, right? Why can't you do the same? You can use the molar mass, just you have to flip it, but you can also go from moles to grams. Well, I have 21.4 moles of HF, right? That's my given information. I put a 1, and the molar mass of HF, if you calculate, will be 20 grams. So if you multiply by 20 grams and divide by 1 mole, then we have our mass of the solute, which is 21.4 multiplied by 20. So okay, so that is 428 grams, right? This number right here is 428 grams, which is also this information. So what is the total mass of our solution? Well, that's just simple. I've put it here. So that would be 1,428 grams, right? So that's our mass of the solution. So we already know this information at the top. We just have to just get it in liters. So now what we have is we know the mass of the solution, right? So let me actually write it. Actually solve it here. So we know the mass of the solution is 1,428 grams. That's your given information, and you can put a 1. And let's get a different color. And we have density of the solution is, this is 1.101 grams per milliliter, right? So if we put the grams at the bottom, okay, and we put the milliliters at the top, well, guess what? Gram cancels out. Now we're left with milliliters. And here's the beautiful part. We just have to, we can finish the conversion in one step here. Just like 1 kilogram is 1,000 grams, 1,000 milliliter is also 1 liter. So 1,000 milliliter goes on the bottom, 1 liter goes on the top. Now we have our answer in liters. So that'll be, let me get my calculation done. So it's 1428 divided by 1,000 divided by 1.101. So that's 1.29 liters. We know now the bottom component of this, and we know the top component, which is this. Okay, so now let's put it all together. Let me just do this in black. Okay, so molarity is, we know the numerator is 21.4 moles, and the bottom portion is 1.29 liters. So that would be, so it's about 16.5 molar. That is pretty concentrated. Okay, that is a pretty concentrated solution. And if you notice, I back up my methods. All I'm left with is this. That's what I wanted. Or you can also write it as 16.5 moles over 1 liter. It's the same thing. But that's exactly how you would solve this problem. Now, if you look at this final screen, that's a terribly drawn picture. It's like a garbage plate. It's got a lot of things on it. So if you're watching this video and you've gotten this far, don't just rewind one step back. Okay, that's not going to help you. Just go to the start, work one step at a time, and pause, and if necessary, rewatch it from the start again. Okay, just don't watch little bits here and there and think you got it, because most likely you won't get it, and you're just wasting your time. Okay, so don't just rewind a little bit, see what you missed. That might be helpful if you have a minor cosmetic confusion about some unit. But if you have a major conceptual understanding issue, I highly recommend you watch this video from the start every single time that you don't understand something. Okay, so now I have broken this problem into components, and now this is the way my brain thinks. Some of your brains might think differently, and you might find an alternate way to approach this problem, but you want to have some kind of benchmark or baseline method, and that's what I have given you. Okay, once you have that baseline method, now you can venture into different ways of doing things. Okay, but that's how you solve this problem. It's not a very difficult problem. But it's a very common question on many pre-professional exams that you would probably see. This is a very, very common question. If you don't believe me, look them up and you'll see. You will definitely find one of these on any of those exams. All right, so I'll see you back with another video where I would work out the last problem in this type of concepts. All right, so stay tuned. Bye-bye.